Automation is still the big new topic in Timberborn. And so far, this automation guide has gone over how both sensors and relays work. But the, quote, real-world implementations that I've shown have been simple. We've got a few gates, timers, and memory around, but I've largely refrained from going too deep into putting them all together. In today's episode, we'll do just that, combining all the aforementioned concepts to create even more complex mechanisms. Tutopolis is a lot of opportunities for automation, aqueducts, powered buildings, and fixing the unworkably low water levels of our dam, which will all require setup conditions more complicated than just a simple sensor and relay. So let's finish up bringing Tutopolis into 1.0 with the final implementation-based episode of the Timberborn Automation Guide. Hello, and welcome back to Tutopolis for the final episode of the automation series. Now this one's going to be a little bit different because unlike the other ones, I don't really have any new topics to cover. It's just going to be me putting all of the information that has been covered in the other two, along with some other stuff from the 1.0 update together, and capstoning both automation as well as just the Timberborn Beginner Survival Guide series in general. So we've got a couple things to do today. We will get to finishing up this dam system so that it is less floody than it even is right now. We're going to be setting up thresholds for all of our powered buildings. I will be showing off a system that I think would be really useful for automating population growth. And in doing so, I will be trying to implement almost all the mechanics that I covered throughout the rest of the guide. I believe there is one memory that I couldn't figure out a good use for, and some of the timers. The oscillator I'm not going to touch on, but I will try to incorporate as much as I can into this map. Before we do any of that, I have one thing that I want to do to start. 1.0 removed sluices from the game, and there are still a couple of places, like down here, where we have them. Old sluices were not removed, but you can no longer place them and you can no longer copy them with the copy function. Because they are technically no longer in the game, I want to go through and I want to replace every instance of sluices that we have on the map. A few of those here, up here, over here, and near our cattail area, those are going to be super easy. And then we have the sluices at the two dams up here. So let's start with the easiest ones first. And actually, maybe we wait a half a day for the drought, and that'll make things a lot easier for us. I'm going to start with these sluices down here. We'll just demolish all of the old ones. They will still give us the same amount that we put into them back as we replace them. All of these will just be replaced with throttling valves. For this, I am just going to use terrain blocks, since the bottom throttling valve set to unlimited will be able to put through enough water, because that is how sluices have always worked, and I'm just dumb. And I just honestly did it wrong the first time. So we'll just have this bottom layer of flow valves that let water through this way, and then we will have dirt on top. For now, I'm going to modify this throttling valve to just be off when it's on, so it should be giving no water through. And then I'm going to modify these two sluices, which will lose us some water up here, but I think it'll be fine. We'll cut those two out, which is going to cause a little bit of a flood here. And then we will come down here and we will replace those with fill valves. These, of course, will work exactly the same as the old sluices did, other than not having the contamination setting. So we will set this target height to about 0.75, and that should keep this area full in the same way the old sluices did. For this one, I'm going to make sure that the access is actually on the old district and not the farming district. because it'll make it quicker to get the sluices and stuff here replaced. And then much like before, I will lower the on here down to off, and I will raise this one back up to where it was before. And then I will destroy all of this, pause it, replace these with fill valves. I will only do a single line of them here. And then levees on top in the same way they were before. These fill valves, I will make a target of 0.6 again. And then this will cause some flooding of this area. But there's nothing really over here, so I think that'll be fine. Speaking of flooding, we will have to lower these floodgates and turn this off, because I don't want too much flooding to happen here. And with that reservoir relatively empty, we can go ahead and destroy this. Replace that with a fill valve. And then replace the path that we have destroyed. Make sure this fill valve is set to 0.5. Actually seems like a pretty good level for that, so we'll leave it there. Then we will let them build all of this. And that is the simple sluices done, which means we have the valves on this part of the dam to replace, as well as the valves over on this aqueduct. And there is technically one more sluice down here, way under the map, way under all of this stuff. I'll get rid of that. I probably don't even honestly need to replace it, but I will. This might cause issues, but hopefully it won't. And we will replace this with another unlimited throttling valve. That'll flood some stuff. That's in, so replace that. And there we go. That's not too catastrophic flooding. And now, because I can close this Badwater source, I will work on these sluices first. So all these sluices up here need to go. We will once again replace them with our throttling valves. I'm using these mostly just because I don't have a fill level I'm trying to achieve here. I have a amount of flow to not overtop this aqueduct. So I'm just going to make these the throttling valves rather than the ones that go based off the level of water. I will need to unlock a contamination sensor and place it down here. And then I will also need a way for our beavers to get down here. So that'll just be a platform and some spiral staircases. And then we will set the sensor to the maximum priority, and then we will let them go. And this should start to flow out just a little bit and then be fine. And then for now, just to replace the function that we were actually using those sluices for, we will make this measurement above 0. For contamination, we'll turn these throttling valves from unlimited to off. And these throttling valves will go from off to about 0.6. I will be making these valves a bit more complicated in a minute here, but for right now, this will be more than fine. And then the final thing to do here, these two sluices will of course need to be replaced once again with throttling valves. However, this is going to be the first place that I automate something. This is going to be the first place I want to get into some more complicated automation. So the other thing I'm going to do, I am going to replace these with dirt. And then to explain what I want here, I want a very slow flow out of these throttling valves, usually. However, if we are in a situation where there's not much power being generated, I want more flow out of these throttling valves, making use of the bad water that is up here. I also want this to be a mechanism that will control the level of the bad water here, so that if the bad water up here is getting too high, it will flow out here faster. So I already have a sensor for droughts. I just need that sensor for depth up here, and then I will need a power sensor down here. So the first thing I need to test is to see exactly how much power having this at 0.65 will actually generate. So it's looking like it's somewhere consistently around 3,000. So that is what this will be. Surplus is less than 3,000. And then this depth sensor is set to just below the top rim of this reservoir. And then we will need 2 relays and 1, not chronometer, and 1 timer. We will set this as ore. We will make it the bad water and the power meter. Then we can name this. And so that satisfies the first 2 conditions, but the third condition that I want is for this to just essentially be open during a drought. I don't think the other 2 conditions are going to be more relevant than just having the extra burst of power whenever a drought happens. So I'm going to set this to ore. The first condition is going to be that first ore we have, and then the second condition is going to be just our if drought. And then the final thing is I don't want any of that oscillating that happens when the input condition is changed by the activation. So both this input and this input are actually affected by the valve here opening. So I'm going to plug this ore into a delay. We don't want the trigger to have any delay, but we do want the off to have a delay by, let's just say, 10 hours. And then we will take these, we will automate them to this timer. The off is going to be when none of these conditions are being met. The on is going to be when any of them are. So we're going to turn the on to the 0.65 that we want here. We will reopen this Badwater dome, and then we will name this timer. And then that will be that reservoir controls, so we can move on to our other aqueduct up here. There's going to be one very simple thing I want to do. This is going to be another batch of ore conditions. One of them is going to be very simple. This is going to be just an ore. We're going to do the contamination sensor and the Badtide weather, because quite frankly I want this to open up immediately upon a bad tide regardless of the contamination, but I also want the contamination, if there is still some in this system, to flush it out this way. I am also going to have another relay set to ore. This one is going to be our original ore over here. And then for the second ore, I also want this to open up if the batteries are getting too low as a sort of auxiliary power to power these batteries, which is going to also require a knot here. So we will hook that up. Although thinking about it, I will need another step here because I will need a delay on that battery power. And then the final mechanism I'm going to want up here is going to be a memory set to flip-flop. As I explained in the previous video, this will capture A when B switches on. So, this one's going to be weird. What I want is for if this mechanism switches on to turn on the throttling valves over here, and it is not enough to power the machines we have, and these batteries are good enough for power, that it will put flow through here. so that we are getting even more power generation. So to that end, I will have B be the timer over here. A will be the clutch control. So the moment this turns on, this will essentially check to make sure that the batteries have enough power and that the clutch is already engaged. And then it will put water through here. We will need one more ore here. And then this final relay, we will make Aqueduct control. And we will come back here and we will automate these throttling valves to that controller. Then we will see that it'll let some of this water spill out. I forget every time that I actually do need a little bit of a reaction speed on this one. And giving it 2 more seconds of thought, the reset should be battery charge being full, not battery charge being low, because that can't happen with this being open. I want it to be when the batteries are full, this resets the whole system. And that is all of the sluices replaced with valves and a little bit of automation to go with it. So next up, let's move on to automating some population expansion. So let's say you're playing, you want to expand population, you've built some houses, but you don't want all of these beds to be open immediately and have an explosion of beavers that you cannot deal with. Now, while you could just unpause these buildings one by one, that's not super efficient. And you would have to constantly be watching your population and these buildings to know whether you should open a new one. And if you're like me, you may be off doing something entirely different before you realize, oh, I should go and open another one of these up. Luckily, there is a better way. And unlike everything I've done so far, it is somewhat expensive to set up, but once it is set up, you don't have to set it up again. You can just keep using it for new housing expansions. The basic idea. We have a population counter. We will set it. District mode is fine. Free beds equal to 0. We will then get a memory. And we will set this memory set reset free beds equal to 0, which I need to rename. And then this memory we can connect to our first house to automate it. Now we would have to unpause this for it to actually take effect. And we'll wait half a second to do that because we need to build the rest of our machine. To continue on, we are going to build another memory. This one will be a latch. Now, B is going to be set to our first memory here. And then you may think that A should just be set to free beds. But the problem is this will just cascade down all of the memories we make. And it will pretty much be exactly the same as if we just connected all of these houses to free beds equal to 0. What we want to do instead is to get a timer. And we will set this to accumulator. What the heck is random? That's new. And we will set A to be memory 2. And then this will start accumulating once this latch is on. And we can set a second house to be connected to that. Now I'm going to have to reset this whole circuit once we're done with this because right now this isn't going to work properly. We will then copy this latch. We will set A to still be free beds equals 0, but B we will set to this accumulator. And then we will build another accumulator. This one we will set to the new latch. We will continue on, repeating this process until we run out of room and have to do the last latch over here. And then from here, we need to reset all of our memory as these accumulators essentially act as memory. We will make sure that all of our houses are set up to a control. And then what we will see, once we run out of beds, which I guess I can just speed along here. This first memory will activate, and it will open up this triple lodge. Then we will need to wait for that to be filled. And then I'm actually going to just pause this one because it's taking so long to hit the 0 free beds. But we will see that this will flip on. The accumulator will start to tick up. And it probably doesn't need to be 10 hours. I could probably make it just 2. Because I just want a little bit of a threshold. And then the second lodge here will open. If we then were to pause this other lodge, we will see that this will pop on. The accumulator will start to tick up again. Then that one actually filled up this time, so we can watch as this accumulator ticks up and we get another open lodge. And what we see where it kind of flips this one on for a second is what I mean with that flickering and just being on the whole time, and why I have the accumulators here in the first place. One thing I do want to point out, though, is while this setup does seem a bit complicated to get going, one thing we could do, if we let these fill up and then move them off of the accumulators, we could have a lever here that is set to reset everything. Just pop that on and off. And then if we wanted to build another lodge, but continue that trend of only opening it up when these are filled up, we can just continue to attach it to these controls and accumulators and do it for another 5 houses and another 5 houses and another 5 houses. So this machine, as opposed to any other control structure we have done, only needs to be built the once. But you can also just build out 5 lodges at a time, reset the whole structure, and continue to use this one setup for every 5 lodges that you build. Because this free beds is completely modular to your district. So with that out of the way and gradually expanding our colony, let's move on to getting all of our powered buildings hooked up to thresholds. So the idea here is going to be complicated to implement, but rather simple to understand. Basically, every powered building draws power, even if it does not have, in this example, a wood workshop not having pine resin to actually make treated planks with. In a different example, we might have more than enough gears, but this is still going to be powered and making gears, even though we have more than we need. So the goal here is going to be pretty simply pausing any sort of powered building if it either has more than enough in storage or cannot get access to its component parts. So let's start with this wood workshop. We're going to need resource counters for this. And much like we did down here with this dirt, we will do treated planks, greater than equal to 99 less than or equal to 25. A set reset memory based off of both. And then we will need 2 more resource counters. One will be planks greater than, we will say, 20%. The other will be pine resin, which doesn't get used for much other than this, so we will make that 10%. Planks I'm leaving at 20% because they're also used in building as well as other materials. And then we will just need 2 relays for this. We will make it an and. We will do our planks and our pine resin, and then another and for that and, as well as the memory. So the ultimate logic here for the treated planks controller, it will be on if planks over 20% of our storage, pine resin over 10% of our storage, treated plank total capacity is greater than 25%, but less than 100%. All of these need to be on, and then the treated planks controller will also be on, and then we will hook both of these treated planks up to this controller, which will free up the bots and free up the power input that the bots were using to run these buildings despite not having the materials for them. So that is the gist of what I'm going to be doing for pretty much any powered building here. I don't care as much about the unpowered buildings since these are not drawing power to run and sit idle, but these ones over here obviously are. Now, these resource counters do require a path connection, so I need to figure out where I'm going to put all this. Maybe up here on this mountain. So I will get going on that. All right, and I've got all of that finished, so we've gone from this small little computation to this, which encompasses literally all of our powered buildings. As we can see, many of them are shut off currently because they are in different states over here. Part of why I wanted to do this was to show just how much space all of this takes up. We have claimed quite a bit of the mountain up here for our memory and relays and sensors and all of that. But we are to the point now where literally everything over here that is powered has a threshold. It has a measure that determines whether or not, based off of the inputs, there is enough for any beavers to be working at the factory, which I guess technically all factories already did. It's just they would sit idle and burn power. So this prevents that. I'm not going to go into every single thing. I've modified some of these values. For example, the metal block threshold here kicks back on when it's at 10. Some of the other ones, maybe explosives, I have kicked back on when it hits 5 because they are less necessary to have a significant backlog of. But that is all of our powered buildings, including the bot buildings, although those I have just put on a normal threshold because I'm pretty sure we're not going to hit a point where we don't have any of these. And I don't really want to risk not making bot parts, honestly. As I've been in the past, I'm still a bit reticent to face the idea of not having bots to work. But that is automating our powered workplaces, and as we can see, we have cut the demand down to about 6,000 here. I don't remember exactly what it was before, but I'm sure that I have got it on screen showing right now. I'm not going to go into the values every single one of these has, but I will be making this save and actually all saves from every episode of Twotopless available. Check out this machinery or any of the other stuff that I've done today just to double check past the video. Then That'll probably be a link in the description, but I haven't fully solidified that yet. But anyway, that is the end of fully automating our powered buildings, which means the only thing we have left is to finally finish automating our dam. So it is finally time to finish up automating this dam. The only thing we have left is pretty simple. I want to control these floodgates so that they store more water. One of the things that happens during a drought is that this and this, which are both based off of pressure from this middle dam, will get to the point where they basically have no water in them. And that is in part because the water here is stored so low based off of this floodgate at 0.5. So we need to adjust the average height of these dam steps. I am going to do that for this top dam, this second dam, and the third dam step. This dam step, for whatever reason, I don't know if it's because the water changes angle, I can't get it to work. So this one is going to hold slightly less water because it'll cause a bunch of flooding still, and then we will deal with this gate at the very end because this one also has an issue where the on state is still honestly pretty low during a drought or a bad tide, and the water down in this section of our water system gets pretty low. So for these dam steps, I want them controlled based off of three things. I want them controlled based off of the height upstream, the height downstream, and also the weather that it currently is. So I don't want these being fully open during a drought or a bad tide because it will end up with a lower water level on these steps. I want them to be fully closed, or it's going to be most of the way closed at least while it is temperate weather, while it is a drought or a bad tide. Though the first thing I am going to do, I'm going to reconfigure this dam again. I just love doing this so much. I promise that was not entirely aesthetic. It does help balance things out a little bit to have it closer to the center of this dam and pouring out closer to the center of this section of the water. But it also was not like imperative. I just felt like doing it. So for example, on this top step, I'm going to add another downstream sensor. We're going to finally use this upstream sensor we have. And the other thing I will need to do is use our old friend, the timer. Now, I'm using these timers because, as with everything we've done today, one of the problems with automation in Timberborn is if you are adjusting something like water height based off of the water height, and you are getting that immediate feedback, things will tend to flicker or oscillate very quickly when they get to the actual activation condition. And these timers will just help us delay the activation. So the condition will have to actually be true for an amount of time before the mechanism will activate and start changing anything. So for example, here with this first timer, I'm going to set it for the top height sensor. I'm going to set it to ticks. I'm going to set it to just 10, and then I'm going to make this bottom one 0. If this top height stays at 4.5 for longer than 10 ticks, this will activate. Otherwise, it doesn't, because this could be fluctuating all over the place, and the water level could be different. And I don't want it activating unless I am sure that we are having above this water level for at least a couple of seconds. This downstream depth I'm going to set to 3 is the top height here, so I'm going to set this to 3 or 2.6. And then I'm going to once again get a timer. I'm going to set this to slightly longer because the mechanism here is going to be dealing with upstream water level. I do want it to be based off of the downstream water level, but I care about the downstream water level less. I will then need 2 relays. I will then set this first relay to and use both of my timers. And this second relay will be that first relay and also our good old not temperate weather. And then I'm actually only going to hook this up to these middle floodgates. And I'm going to make this 0.65. And I'm also going to make this or, not and. So we will see that these 2 middle floodgates will then turn on, making them equal with these 2 other floodgates. And what we should see here is that this top dam will gradually average to be higher than this 4.65 because that is what our floodgates are set to here. And it will do so without having that oscillating back and forth that our water system tends to do. Now we will see that right now it's kind of going back and forth between this 0.45 and this 0.65, and that is because we need to do this for the rest of our dam. Otherwise, this will not be consistent because it is also going off of downstream level. So let's set this up for our middle and lower step as well. So I'm going to get even more depth sensors here. And for these, I'm generally trying to keep them near to kind of the middle of these dam steps. I do think that's part of what with the earlier measurement system that we had was causing an issue, was that these sensors I was placing then tend to be near the front or the back of the dam step, and it's not giving us a kind of average height. And I've realized this top dam I've got set completely wrong. I want it less than and I want it much higher. So we've added a sensor that step 3 is less than 2.9, a sensor that step 2 is less than 2.9, and a sensor that step 2 is greater than 2.6, and also a sensor that step 1 is greater than 2.6. So then we will just need to replicate our 2 relays and 2 timers. This first one, top not flooding, second one, bottom over 2.6. We will do an and of both of those and an or of that and the temperate. And then we will once again lock these middle 2 into the floodgate control. The on shall be 0.65 to match with these 2 middle height floodgates. And then we should gradually see that this height measurement of step 3 starts trending higher than 2.6. Now this will probably take a minute to really balance out. It may even take after the next season before that is fully shown, but we are seeing that it is tending to around 2.7. And now we got to do it for this second step as well. Why do I have a bunch of farmland down here? So we will do the upstream depth. We will do the downstream depth. And then we will once again plug this into the controller. And our on height will be 0.65 with the off height being 0.45. I'm not sure why it was 0.5 before. So just to once again reiterate my thought process, because I'm not sure I explained it adequately before, these floodgates are down if the downstream depth is low or the upstream depth is too high. The thought being, if the downstream depth is low, I want water flowing more. If the upstream depth is too high, I want more water flowing as well. Otherwise, I want the 4 middle floodgates on each of these steps to be exactly the same at 0.65. That is why the height I am shooting for here is 0.6, because that is essentially the lowest target height, and why this one is slightly lower because this floodgate is going to stay as it is, since for whatever reason I don't really know. It still deals with quite a bit of fluctuation down here, and leaving it as this adjusted height floodgate will balance out all of the flooding that was happening before, along with the system that I have implemented here. Now, as always, I'm not claiming this is the only system. I'm not even really claiming this is the best system, but it is the system that I came up with. So it's the system we're getting. And then, as I said, I want to do one final thing with this dam. We have a bit of a problem with this floodgate in particular. That is that it's set between 0 and 0.6, which is okay during temperate weather. But once we are in a non-temperate season, it means that there is often not very much water being stored in this downstream bit of our water system. Because sometimes this will be sitting at 0.0 as water is still moving through the system, even though our source blocks are no longer outputting water. Sometimes it's just that this 0.6 is not really holding that much water down here. Now, unfortunately, one of the few things that I feel is missing desperately from this automation system is the ability to set different heights based off of different conditions. Floodgates only have 2 states, on and off. So we have no way of making these floodgates, for example, just close all the way during a bad tide or a drought. Luckily, we don't need it to be these floodgates. If I simply take a second set of 1 high floodgates, set them up on this series of platforms, I will need to turn these off from synchronizing with adjacent floodgates. It's because otherwise they will synchronize with these. I will then turn them on to automate based off of our not temperate weather. I will set the off to 0 and I will set the on to 1. I will then need to make sure that I press V and copy this to all of the adjacent floodgates because they're not synchronizing. And then what we should see in 2 days once the drought hits, our inner floodgates here will go all the way up to 1.0. The outer floodgates will continue to pop up and down as they do, but we will no longer be losing water flowing out of this floodgate during a drought or a bad tide. And that ultimately is going to do it for us with this dam project. So while we wait for this drought to finish up, I'm going to go through and I'm going to do a little bit of implementing a few more fun automation things as I go. So let's get to that. And with that, the final drought has ended. We will wait for a few moments here as the reservoir fills back up. And as we will see, our dam system will fill up and hopefully not overflow. Well, I guess it will help if the aqueduct in the back activates early too. So I will call that damn automated and this automation guide over. I hope that if you have watched all 3 parts you have enjoyed. If you watch these as they come out, I apologize for how long it took me to get this 3rd episode out. I was ill and then lost my voice, so I had to take a bit of a break from recording these, but it's out now, and if you're watching it after April, that doesn't matter to you. As I said earlier, I'm going to be putting up all 20 saves of Two Topless from the 1st episode until now. I'm partially doing that because 1.0 got rid of waterfalls, and on top of that, I've done a lot of automation here. I've adjusted some things. Some values ended up lower than others, like down here, this ended up at, I believe it's 2.3. It was not going to let me click on it. 2.3, so that it is below the 1.35 floodgate here. There's a couple things like that I adjusted numbers on the fly and may not have mentioned it in great detail. There's obviously a bunch of numbers that have been changed over here, and maybe you want to see those. So that'll be out there. Hopefully by the time this episode comes up, it may be a week or 2 later. As always, you can join my Discord if you want to continue to see Timberborn or whatever videos I make in the future. Otherwise, thank you so much for watching what is very likely to be the actual final episode of Two Topless, unless Mechanistry has some sort of post 1.0 update or DLC up their sleeve, in which case we will be back here. I appreciate all of you. Goodbye.